Hi, my name is Vernooy. I'm from Niskayuna, New York, and I worked on the research project Hacking the Election, which aims to measure and solve the political phenomenon known as gerrymandering. Gerrymandering is when politicians manipulate boundaries of districts to gain an unfair political advantage. This splits communities and hurts our democracy. Several existing methods attempt to measure gerrymandering. However, these are either inaccessible to citizens due to the required use of a supercomputer or inconsistent in their detection of gerrymandering. Our primary goal is to quantify gerrymandering in the US. We will then use this quantification to create districts that maximize representation. Our process required boundary and election data for geographical units known as precincts, which we gathered from open source resources. We wrote software in C++ that implements our methods, which we ran on the 27 states we were able to find data for. In order to measure how gerrymandering splits apart communities, we must first find these communities of like-minded voters. To do this, we create groups of precincts which we optimize for several constraints. Most importantly, we try to minimize the standard deviation of the partisanship of precincts in each community to find areas of like-minded voters. We do this with a multi-objective optimization technique known as the iterative method. Once we have this map of communities, we can measure how districts split them apart. For each district, we find the community that it attempts to represent. We then measure the percentage of people that are in that community but not in that district. This measures misrepresented voters. They are not being represented by their community's district. This is our gerrymandering measurement. With this measurement, we can create districts that optimally represent communities. We do this by algorithmically modifying the community map to comply with district population laws to create a district map that is as similar as possible to the community map. We found that all our algorithm-generated districts were significantly less gerrymandered under our measurement. Our districts were also notably less gerrymandered under another existing measurement called declination. In conclusion, our algorithms were able to detect famous cases of gerrymandering, such as Pennsylvania and North Carolina. Our algorithm-generated maps were on average 78% better than current districts under our measurement and 68% better under the declination score. In the future, we hope to update our community maps with the 2020 census and presidential election data and quantify the 2021 redistricting proposals. Finally, we aim to measure the illegal practice of racial gerrymandering. We hope to quantify this by modifying our algorithms to detect racial communities of interest.